and hello everybody. Today, like already David mentioned, we will talk about CameraX. As humans, we have emotions and feelings, and one of the best ways to capture our emotions is to take pictures. Actually, some of our greatest experiences are captured in pictures. For sure, we have pictures from birthday parties, or holidays, or even from travels. We also like capturing photos with tasty food or even with good-looking cocktails. For sure, we have enjoyed participating at awesome tech events, and usually we like capturing the happiness or even the emotions generated by bad surprises. In the latest year, we discovered that we love taking selfies. The pictures help us evaluate how our life has changed, or they can help us to concentrate on a specific time or feeling. Currently, social media has improved the importance of photos. They enable us to express ourselves. We all know that a picture is worth 1,000 words, and we actually feel the need to capture moments from our life because photos help us to tell our stories. Self-portraits are about self-image, how we define ourselves. And there is also a psychological concept called the looking glass self that says that how we see ourselves doesn't come from who we really are, but rather from how we think others see us. Okay, so I think it's crystal clear that we like to take photos, but how many photos do you think are taken yearly? Based on the stats, the past year we took about 1.42 trillions of photos. This year, the research shows that we will capture about 1.43 trillions of photos, so there are a lot of photos. Now that we know how many photos are taken yearly, let's see what are the devices used in order to make these pictures. And we have three main categories. We have the digital cameras, the phones, and the tablets. In 2018, these were the numbers. In 2019, the numbers were a little bit changed. And this year, based on the stats, the phones continue to be on the first place. So the trend is ascending. What is important to understand from here is that a big part of the photos are taken using the phones. Since we are Android developers, let's see what are the challenges of using the camera APIs in building an app that takes photos. There are three main different kinds of challenges. The first one, we must manage to build apps that work on different Android versions. And we have a lot of operating system flavors since Google launched each year a new Android version. The second one is represented by the platform fragmentation. The apps we create are running on different kind of devices, and in terms of configuration and price, there are different kind of devices like entry-level devices, mid-range devices, and premium devices. The third challenge is represented by the complexity of the camera API. What do I mean by that? In terms of camera APIs, we have the legacy one, or Camera 1 API. After that, Camera 2 API was added in API level 21, or Android Lollipop. Indeed, it added some improvements, but in terms of using it, it's supposed, again, to write a lot of code and also to make sure that we handle properly the lifecycle of the camera session. At Google I/O in 2019, CameraX was released. It is part of the Android Jetpack, and it's actually a wrapper of the Camera 2 API. And the purpose of this presentation, like I already mentioned, is to learn more about this new API. Now, let's see how the discovery challenges are solved by CameraX. Let's start with the first one. Since CameraX is a wrapper for Camera 2 API, it means that it's compatible with L+ devices, which means Android 5 or Android Lollipop. So by using this API, we cover about 90% of all Android devices. The second challenge related to the fragmentation Even if our app runs on the same API levels, there are a few things that can be different across devices. For example, the hardware abstraction layer can have a big impact on the performance. To solve this issue, CameraX team has invested a lot of time in automation. They created a lot of automated tests, including building a dedicated test lab with a big range of devices, all with the goal to have consistent behavior across devices. And the last challenge related to the complexity of the API, it's pretty easy solved because CameraX provides an easy to use API, and the purpose of this presentation is to show you how this could be easily integrated. One of the first advantages of using CameraX versus Camera 2 is that the number of the lines of code written is reduced by 70%. There is also a case study about Monzo, and they reduced over 9,000 lines of code and improved registration dropout by 5 times with CameraX. Just like other Jetpack libraries, one of the core properties of CameraX is represented by the lifecycle awareness. Instead of having to manage the opening and closing of camera devices and sessions, CameraX takes care of this on our behalf, as long as we provide the lifecycle owner. So when the lifecycle starts, so does the camera. When the lifecycle stops, we don't need to worry about closing either, because CameraX does that for us. Another core principle of the CameraX is represented by its use case-driven approach. Actually, use case in this schema, it's an abstract class. And at this moment, in the current version of the API, we have 3 different implementations of this use case. We have the preview, the image capture, and image analysis. We will cover each one of them in the next slides. Let's start with the preview, or getting an image on the display. First of all, we will review the implementation steps. For each use case, we have some steps that should be covered, and each step has its own color, also here in the schema, and also when I will show you the code. So, the step number 1. First of all, we need to add the Gradle dependencies. After that, because we are working with a hardware component, we need to handle the permissions. The step number 3 is represented by the fact that we need to add a preview view in the layout. Step number 4, get an instance of the process camera provider. And finally, we just select on which camera we want to run the preview and bind that use case to the lifecycle. Let's see the code for each step. Step number 1, Gradle setup. We will work with Java 8 version. And right now, the CameraX is in beta, it's in beta release. Reaching this beta status means that a Jetpack library is considered to be ready for production, but it may still contain some non-critical issues. After we define the dependencies in Gradle, we are able to handle the permissions. First of all, we add the permissions in the manifest file. By adding Android hardware camera any, make sure that the device has a camera. Specifying any means that it can be a front camera or a back camera. If we use this feature without any, it will not work if a device, for example, doesn't have a back camera, like most of the Chromebooks. The second line from this code sample, adds the permission to access that camera. After we added the permissions in manifest, we just need to handle them in the Kotlin code. I think it's a familiar code, this one. We ask the permissions to the user, and the user should, if they are granted, we will start the camera. If not, we will request those permissions from the user. Step number 3, add the preview view in a layout. This is the XML file, part of the XML file of our layout. And since beta release, preview view is the recommended way of implementing camera preview. If we want to use our own surface, then we must implement our own surface provider, and we also need to handle the sizing and orientation appropriately, which will be tricky. Let's see what's happening behind the scenes regarding this preview view. This class is actually a custom view that displays the camera feed for this preview use case. It extends the frame layout, which already know that it's a view group. Behind the scenes, Preview view is using by default the surface view. But if the camera device is running in backward compatibility mode, behind the scenes it will use texture view. Other than specifying the preview view in the layout, we also need to take it in the Kotlin code. And we also initialize the preview object, which is our current use case, by creating a reference of it. After that, the next step is to create an instance of the process camera provider. This class is a singleton, which can be used to bind the lifecycle of camera to any lifecycle owner. Only a single process camera provider can exist within a process, and it can be retrieved using this getInstance function applied to the current context. After that, we make sure that we'll bind the lifecycle of camera to the lifecycle owner, and we will also need a camera executor. This is actually an executor that will run on the main thread. When we apply the listener to the camera provider feature, we have two arguments that should be provided, a runnable and an executor. The code for runnable, we will see it in the next slides. I already mentioned that in step number 5, we will select the camera. What does this mean? It means that we could specify if it's the back camera or the front camera. And in order to apply it, we have the require lens function. Okay, so we finally need to bind the new use case, this use case to the lifecycle. But first of all, we need to unbind all the use cases before unbinding, because maybe previously we had a different approach or different use cases applied. Unbind all does this thing. Sorry. Also, in order to bind the preview use case to the camera, we have bind to lifecycle function, and we just specify as one of the arguments the preview use case. And finally, we set the surface provider, which in our case is the preview view. This is actually the code that will be included in the runnable, and I also added there a small star that it should be included inside of a try-catch, because this code could fail. Could fail because maybe our application is no more in focus and bad things happen. And let's summarize, this is the entire code we need to write in order to achieve this preview use case, and don't forget about the try-catch. How does it look in a real implementation? I have here a small video with this preview use case implemented in a sample app, and this is how it works. The video is a screen recording of that app. Let's move on. Capture use case or save high quality images. Again, we have some implementation steps. Each step has its own color here in the schema and also in the code samples. First of all, we need to create a reference of the image capture. This is the implementation of the use case. After that, we could add the orientation event listener. This one is an optional step. Step number 3, because we want to capture a picture, let's say that for this scenario, we want to save it inside of a file. So we need to provide a file where the image will be saved. We need to call the takePicture function that actually triggers this action of capturing the picture. And finally, we just update the call to bind to this new use case to the lifecycle. Step number 1, create the image capture reference. We have a builder, and this case it's actually the simplest implementation we can have. If you want to have more control, then some methods are provided. For example, if you want to set up a different photo capture optimization, we have the set capture mode. We have the possibility to optimize photo capture for quality or for latency. The default option, if we don't provide any other option, will be the latency one. To apply it, we have set capture function. We also could specify if the flash will be on or off, or even auto setup. To do that, we will have the set flash function, and the default setup is the flash mode off. So if we don't provide this call to the set flash mode function, the flash mode off will be set. We could also specify the aspect ratio, and the default one is 4:3. And we could also have the opportunity to use 16:9 standard aspect ratio. To apply, we have set target aspect ratio function. Other than that, sometimes we need to decide what resolution to apply. If it's not set, the largest available resolution will be selected to use. For debug purposes, we have set target name, which specify a name for our implementation. If we don't provide a name, a unique name will be automatically generated, and it's actually a combination between the canonical name of the class, and a unique ID. Okay, step number 2. This one I already mentioned that it's optional. I added here the sample code for setting the orientation of the capture. We have actually an orientation even listener that it's created here, and we override the onOrientation changed function. If we don't provide this orientation even listener, the default value will be display.getRotation. Okay, so we set up the capture. Now let's set up the file where we want to save the image. Output file options give us options for saving the captured image. And these output file options will be provided as an argument for the takePicture function. This takePicture function, other than the output file options, which will provide the file where we want to save the picture, has a camera executor, which in our case is an executor on the main thread, and also a callback that contains 2 functions: on image saved, which represents the fact that the image was successfully saved, and on error, when something bad happens when we try to save the image. And finally, for this image capture use case, we update the code in order to apply this image capture use case to the lifecycle. For takePicture, we have 2 different implementations. There is one which contains only 2 arguments, and actually this method provides an in-memory buffer of the captured image. And the one that I already showed you in the slides, this method saves the captured image to the provided file location. Let's summarize the code. This is what we should write in order to achieve the image capture use case. It's pretty straightforward. And let's see also an example of the image capture from the same app. If the user presses the button, the image will be saved at the desired location. And the text view is populated, which means that the image was saved. It was saved successfully. The third use case, image analysis. It offers us the possibility to make image processing or apply computer vision algorithms. Just like we are already used to see, we have some implementation steps. First of all, we need to create a reference to the image analysis use case. Then we define a custom analyzer. Let's see that for this implementation, we want to create a custom analyzer that will compute the average number of the purple pixels from a picture. And we will see how this thing will be done. We implement the analyze method, so we compute the average of the number of purple pixels from a picture, and we set this custom analyzer, and finally we just bind the image analysis use case to our lifecycle. To create a reference, we also have a builder, and this is the simplest way that we could use. Just like for image capture, we could set up some extra features. But before we will talk about those extra features, actually image analysis acquires images from an image reader. These images could be processed in 2 different ways. They could be processed sequentially or only by using the last available frame. So actually, we have a back pressure strategy added by using the set back pressure strategy function. And we have these 2 options. The First one when we process sequentially, strategy block producer, and the second one when we process just the last available frame. And this is the default implementation. So actually we have two working modes. We have a blocking mode and non-blocking mode. The blocking mode is for strategy block producer, and we also have a function, get image queue depth, that gives us the number of the images available in the pipeline, including the one that is currently analyzed. And when the analyze takes longer than the latency of the frame rate available, then the new frames are blocked until the method returns. And for the non-blocking mode, for the analyze function, if it takes longer than latency for that frame rate, then some frames might be skipped and it will process only the last available frame. I mentioned that we could add some extra features for the image analysis use case, just like for the image capture. We have set target aspect ratio, we have set target name for debug purposes, set target resolution, and set target rotation. Okay, now let's move on to the step number 2. To define a custom analyzer. We will call this analyzer purple color analyzer, and it will implement the image analysis analyzer interface. And inside of it, we need to override the analyze function. So the implementation for the analyze functions look like this. We get the pixels that are purple, and we compute the average of them. An important thing to mention here is that before returning from analyze, we need to close the image reference by calling image close, image.close, to avoid blocking the production of further images and to avoid potentially dropping images. And step number 4, just set the custom analyzer, in this case our purple color analyzer. And finally, bind this new use case to the lifecycle. To summarize the code, we have this slide. It's, again, not so much code that should be added. And for to see a real example, you see that I changed, I moved the device, and inside of that picture, I have many purple pixels, and when I go up, the number of the pixels goes down. Okay, CameraX produces images in IUV format. What is this new format? I will cover this new image format in the next slides, and we will take each part of the name of this format. For example, I can say from now that 888 represents the fact that we have 8 bits per color sample. So this is why we have 888. I think we all know the RGB color system. Is the one that constructs the colors from the combinations between the red, green, and blue. The IUV color encoding assigns actually 2 dimensions to the pixel, the brightness and the color. So it separates these 2 different properties of a pixel. In terms of concepts, for IUV, there are 2 new relevant concepts: the luminance, which refers to the brightness of the pixel and is represented by the I from the name of the schema. It's actually the grayscale image, and the chrominance, which refers to the color and represents the UMV from the schema name. Actually, the IUV format could be fine also as ICBCR color scheme. CBCR means chrominance of blue, and CR means chrominance of red. It actually represents how the blueness of the pixel and the redness of the pixel. There are some mathematical formulas that could be applied in order to transform a color from RGB to IUV, and the other way around. I'll leave them here if you need them. Okay, the schema of this IUV format is a little bit different than the RGB. We see that the red appears on the top left corner, and the blue appears on the right bottom corner of the schema. So in order to get green, we need to have negative values for those two colors, for green, for blue and red. And we also have different a different scale of values. The research shows that the human eye sees very well the brightness of the colors in an image, but doesn't see so well the colors. So from here it appeared the chroma subsampling concept. Chroma subsampling is actually a compression technique used for images and videos. And it focused on the fact that the information about the brightness of an image is more important than the colors from it. So even if we compress the colors, if we keep the same brightness, the human eye will not see the difference. And in terms of this chroma subsampling, we have three common schemes: 444, 422, and 420. The latest one is the one that we have in CameraX. So all the images has this 420. But let's see what does it mean, this compression technique, how it is implemented. Let's say that we have this picture, and when we apply a chroma subsampling schema, it means that the image is fragmented in blocks of pixels, and those blocks of pixels are compressed based on the defined schema. And let's see that right now we want to process a part of the area that is with that orange circle. So if we zoom in, we see only the pixels. So we will get blocks of height of 2 pixels, and they will have the width of 4. So actually the first 4 represent the number of the pixels that we want to process. So how many samples are used? The second, because we talked that the brightness is very important for the human eye, we will put it separate, and we will focus only on the colors, and we will try to compress them. By using this schema, the second value of the name represents how many samples are used in the first line. And here we have 4, so we will keep exactly like we have it. We don't need to compress anything. The third number from the schema name represents how many samples are used on the second line. Again, we have 4. We initially have 4. We kept also to 4. For the 422, we will get again a block of pixels with height 2 and width 4. And again, the second value represents how many samples are used in the first line. And right now we have 2. It means that we must compress the colors to have only 2 colors on the first line. So we combine the first 2 and the last 2. And for the third value, it means that how many samples are used in the second line. And again, we have 2. So we need to compress the first 2 and the latest 2 pixels from our schema. So this is how we compress the color. And the last example is the one that we use in CameraX. Again, we take a structure, a block of pixels with 2 lines and 4 columns, and the second value from the schema represents how many samples are used in the first line, and we have 2 with 2, so we get only 2 colors. And the third value is 0, and it means that we should copy the color samples from the top. So in this case, we will have only 2 colors for all the block of pixels. To summarize the chroma subsampling compressing technique, we have the luma, which represents the luminance or the brightness of the pixels. We have the chroma or the colors, and the result is luma plus chroma, which represents actually the compressed image. And we already know that the latest one is the one used by CameraX. So chroma subsampling actually reduced the resolution of the color component, so it reduced the size of the image without affecting the perception of the human eye. Okay, so we saw how we could compress the images, but how much data we save? For IUV 420888, we save actually 50%. So I think it's a good deal. Another important concept from CameraX API is represented by the camera controls. They provide various async operations like zoom or focus and metering, which affects actually the output of the all use cases we already saw. Also, camera info plays an important role here because it's actually an interface that it offers us information about the camera. And we have a different example here. We could cancel the focus and metering, or we could enable or disable the torch, or set a linear zoom by using values between 0 and 1, 0 and 1 in a float type. Or we could also set the zoom ratio or the focus, set up again the focus and the metering. Let's see an example. I have here an example that will handle the state of the torch, if it's on or off. We get the camera control reference and the camera info, and in order to see when the state of the torch is changed, I used here live data. So if the state is on, we will do some actions. If not, we will do anything else. So this is how it should be handled. How does it look? I have a small button on top right, and that one will enable or disable the torch. And you will see that sometimes the image is lighter and sometimes it's not so light, it's darker. Okay, we talked about the preview view, which is the recommended way of viewing CameraX implementation. There is also another view in the API, in the documentation, which is called camera view. This one is not ready yet. I mean, it's not recommended to use it, but I'll show you a little bit about the flavors it offers. Again, it's a custom view, extends frame layout, and actually it's a view group. Other than that, it offers three functions: take picture, start recording and stop recording, and also offer a capture mode possibility. We could use image, mixed, and video. If you use mixed, it means that we could record and in the same time take some pictures. In order to have consistent behavior across devices, Google used a big amount of devices in order to test the CameraX library. You could get a list of those devices in the official documentation, and I put it also a link in the resources slide. There are actually 52 different kind of devices representing 200 millions of active devices in order to have more confidence in this library. They provide unit testing, integration testing, functional testing in order to make sure that the library works good on all these kind of devices. Other than that, CameraX is integrated in the LensGo application. So Google has feedback from how this library works based on how the users interact with LensGo application. Extensions. Extensions are some dedicated APIs for the vendors, and they offer optional effects like HDR or portrait, night mode, and so on. The architecture of the extensions is somehow separated. So extensions are separate from the Camera 2 core of CameraX library. And in this diagram, the red arrows indicate the main data flow when a user triggers an extension. At this moment, we have this abstract class, image capture extender, and it has two abstract functions: enable extension and is extension available. In the API, we have at this moment 5 different implementations for auto effect or beauty effect or bokeh or HDR or night mode. And it's important to mention here that these extensions don't work on all the devices. For example, I know that it works on Samsung devices, the S10 series, and on the newest devices from Huawei. An interesting thing is that bokeh maybe you already know, represents, it's an effect that means that the background is blurred in order to put the focus on a subject. Bohe means blur in Japanese. Now let's see what are the implementation steps in order to enable an extension. For this extensions implementation, we actually have only 2 steps. First of all, we need to create an extender object, and after that, we enable the extension. We will use here for the code example, the beauty image capture extender. We create a reference, and after that, we just enable the extension by calling the enable extension function. We could also check if this extension is available by using the is extension available function. The check part is optional. So this is how we know if that extension is provided or not by our device. If it's not provided and we just call enable extension, nothing bad will happen. Just the fact that the user will not be able to access that extension. Now, let's summarize. We discovered that CameraX offers backward compatibility with the L+ devices, since actually CameraX is a wrapper of the Camera 2 API. Other than that, we expect to have a consistent behavior across devices. And an important thing that was done in order to achieve this thing is the test lab devices, on which Google tests all the time the new changes in the API. Other than that, we see that it's an easy to use API. We already have in place those use cases. Like any other lifecycle, any other Jetpack libraries, it offers lifecycle awareness, so we don't need to worry about when the camera should start or stop, and also to synchronize those states with the lifecycle of the activity or of the fragment. And a new thing is related to the fact that the CameraX has this use case driven approach, which means that we have in place some use cases that are already implemented, like preview, image capture, and image analysis. And don't forget also about extensions. They are not available yet on all the devices. It depends on the vendors. But in order to enable them, it's very easy to do that in the code. If you want to learn more, you could check the official documentation. There are also some great articles on Medium, publication of the Android developers. There's also a very nice podcast about this subject. And the last link represents the devices on which the CameraX library was tested. Thank you very much. And if you follow me on Twitter, these days I will post the slides and also the sample code if you want to check it. Thank you.
Thank you, Magda. So we have 4 questions on Slido, so I will read them to you.
Okay.
So first question is about video capture.
Yeah.
It's pretty important for a lot of apps to support both image capture and video. They say that CameraX is feature complete, but video capture is still restricted. What do you think?
Yes, that camera view will actually handle this use case. I saw they don't provide any code examples for video capturing. That camera view that I already covered in the slides has this start recording and stop recording functions, and also the video capture mode. So for sure they will let us know when it's ready to be used. Until then, we could use the existing approaches. I hope I was clear.
Okay. So the next question is, are you using CameraX in production for some big app? Did it remove like crashes or issues?
Mm-hmm. Honestly, I right now is not in production. Like I already mentioned, the current version is beta, so they said that if it's in beta, it's production ready. Indeed, they have some issues, but they are not so critical issues. I mean, they are small issues, and I saw that they are very active. There is a thread on Google Groups about where we could let the team that works on CameraX let the team know about those issues, and we could also send an issue on the repository of the CameraX. But it's pretty stable right now, and I know that Monzo, for example, is using this CameraX in production, and they said that it was a good approach, and they saved a lot of lines of code, and also they improved the user experience.
Thank you. Next
Thank you too.
question. So some devices don't support binding many use cases at the same time. So specific problem throws error at the third use case. Is
Okay,
there
so anything we can
anything
do
you
about
can
that?
do about that?
Okay. Honestly, I don't know exactly what was the combination that throw that error. They say that in the documentation, they say that those use cases that they already have preview image capture and image analysis should work on L plus devices, on all L plus devices. Um, the only thing I could say is that you should make sure that you unbind all the use cases before you bind again the use cases to the life cycle. Because yes, when I firstly start to work with this library, it was in alpha. I forgot to unbind. I didn't know. I didn't read correctly the documentation. And if you don't unbind the use cases at the beginning, you will not be able to run all those use cases in the same time. And also in the slides, for the bind to lifecycle use cases, I add them each one of them separately, but you could also create a list of use cases.
Okay,
And if
thanks.
the error will still appear, we should raise an issue on their library. Custom filters to photos, preview video at the moment. Um, I think for this question, does CameraX support adding custom filters to photos, preview video at the for this question, you should try image analysis. It depends on what kind of filters you want to obtain. For example, I in the slides I had that example with checking the purple pixels from a picture. I know that you could combine with OpenCV or even with machine learning kit from Firebase in order to process heavily the images. For sure, for preview and photos should work. For video, not yet. Okay, thank
Okay,
you.
last
And what
question.
kind of requirements, constraints we can set on the video frame capture throughout and quality of the camera frames, like constant frames per second? You could only handle the properties that I already mentioned from what I know. You could only handle the resolution, the aspect ratio. The frame rate, I think, is depending on the hardware you have. Honestly, at this moment, I don't know if it's a specific property for this one. From what I know, it's not, but I could check and I will answer on Twitter at this question. Very much.
Thank you. So thank you, Magda. Magda will now go into the 3D world. She will be at the speaker's corner. You can find her there and ask maybe more questions. The speaker's corner is next to registration. It has a title for this stage, and. If you are in the 3D world, you can also visit our partners booth. There are some surprises for you in the 3D world and also in the real world. And now I will enable rating. So rating is now enabled in Slido. You can vote for Magda's talk. Please rate so she has some feedback. And we will meet again here at the desert stage at 17:10, 5:10 p.m. So thank you.
Thank you very much and have a nice afternoon. Thank you.
Bye bye.